Section 2.3, using deductive reasoning to verify conjectures. Deductive reasoning is a much more formalized process than inductive. Inductive relies on patterns, observations, and specific cases. Deductive reasoning that is using logic to draw conclusions from given facts, definitions, and properties. So facts, definitions, properties that we know to be true versus patterns, observations, specific instances. So there's a myth that you can balance an egg on its end only on the spring equinox. I have no idea what this myth is about, but let's just kind of go down the rabbit hole together, okay? A person was able to balance an egg on July 8th, September 21st, and December 19th. Good for them. Therefore, this myth is false because none of those dates is the spring equinox. Now, we're looking at three specific cases, three certain dates. Because we're looking at specific cases where it happened a handful of times, that is inductive reasoning. You have not shown that it works every day other than the spring equinox. They've only shown it 3 times. There's a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above Earth. That's pretty impressive. The moon is about 270,000 miles from Earth. Therefore, the myth cannot be true. So you can barely see it at 180 miles. Would you even be able to see it at 270,000 miles? Based upon the rules of physics and light and distance, notice how we're talking about properties and laws, things we know to be true. This is deductive reasoning. So noticing the difference between these two, are you looking at specific cases or observation, or are you using facts, definitions, and properties to back up your reasoning? Now we have some formulas to help us out for some of this. Okay, the law of detachment and the law of syllogism. Now the law of detachment, if P then Q is a true statement, so we have a true conditional, and we know that P is true, then Q is true. So kind of the formula we're looking at, if P then Q and P, then Q. So, for example, if you have 5 $1 bills, then you can exchange it for a $5 bill. And guess what? You have 5 $1 bills. What can you do? You can exchange it for a $5 bill. All right, so a true statement exists and you have the hypothesis. That means you can conclude the conclusion. The law of syllogism. If P then Q and Q then R are true statements. So you have 2 conditional statements that are true, and we have this repeat information. Q is the conclusion once, it's the hypothesis another time. Then P then R is a true statement. This is kind of like the transitive property. If A equals B and B equals C, then A equals C. You can just piggyback over that repeat information. That's the law of syllogism. If P then Q and Q then R, you can go from P straight to R. So you have P then Q and Q then R. Then you can skip over that repeat information. So we're going to kind of mark up and annotate these problems, okay, to try and boil them down to what we need to know. So if the side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters, so there is a piece of information. Side lengths of a triangle are 5, 12, and 13. Let's call that P. That's a piece of information. Then the area of the triangle is 30 centimeters squared. Now that's a piece of information. It's a new piece of information, so we'll call it Q. Then they're saying the area of triangle PQR is 30 centimeters squared. Now, we already had a piece of information like that over here, 30 centimeters squared. So this is Q again. So that's what we have. If P, then Q, and Q. Conjecture. The side lengths of triangle PQR are 5, 12, and 30. So this right here, we saw this piece of information before. That's P. So now let's look at what we have. What we have is we have if P, then Q, and Q. So we have if P, then Q, and Q. Our conjecture was then P. Now look at what we have, and look at the formula for the law of detachment. Do they match up with each other? They do not. So this is not valid. Could it be true? Absolutely, it could be true. You could also have a right triangle that has a base of 15 and a height of 4. Well, then it's not true. So this is not valid. It doesn't work every single time. Leave that up here as a bit of a counterexample. So the next one, example B. Given, if a figure is a kite, so there's a piece of information, a figure is a kite, we'll call that P, then it is a quadrilateral. Okay, so it is a quadrilateral. New piece of information, let's call it Q. If a figure is a quadrilateral, same piece of information, we'll use the same color and same letter, Q. Then it is a polygon, new piece of information. It's a polygon, new piece of information, gets a new letter, R. So now down to our conjecture. If a figure is a kite, so a figure is a kite, that's red, that's P, then it is a polygon, that is green, and that is R. So what we have P then Q, and Q then R. Our conjecture was then P then R. So do we have our formula? Yes, we do. We have repeat information. One time it's a conclusion, one time it's a hypothesis, and then our final conjecture skips over that repeat information. So that is valid. So the remainder of these examples kind of take the lead from what I've been doing. I've been annotating, marking up the diagrams. Each new piece of information gets a new letter, and then arrange it into what we have, see if it matches one of the formulas. You can check my completed notes online for the answers.